Hey folks, welcome. We are so glad you've tuned in this afternoon. It is Mathline. It's a great place to be. You want to be with us? I know you do. So tune in, call in, do all sorts of good things. Yesterday we had a great show. Had 5 back-to-back calls. In fact, one, Justin, we kind of got left out a little bit there. We'll see if we can hear from him again today. We got it started, but hopefully finished it on his own time there. But anyway, thank you for tuning in. We are glad you're with us. And you know what? What are we going to do to get started? Well, you're going to give us calls, right? 844-686-2378. We've got operator waiting to take care of you. What are we going to do when you get there? You're going to give us a math problem that we can work out live together on the air and have a good time doing it, all right? It's the last day of the week, last live day anyway for us. We're going to have specialized segments tomorrow, but this is your last chance to call in for this week with those math problems. So let's start it. Well, yeah, while you're calling, I think we need to be looking at what? Problem of the day. Let's see what we got there. And it's a humdinger today. Evaluate the expression, and that expression is, wow, negative 4x, and then we got a parenthesis, 2x plus 5 plus 3y times 6 minus y. Woo! And then we're going to say that x is 3 and y is a negative 4. All right, so we want to make sure we have all those good things going there. That's our important moments. So, hey, my friends, let's check and see what we're going to do with this problem. All right. So first things first, some of you are saying, well, Ernie, are we just going to go straight on with the substitutions, or are we going to run the distributive property through and work it from there? Either way is a good idea, right? Because it's still going to come out just fine. It will. Trust me, we'll get the same thing. In fact, we might even have time to work it there if we have a little slowness on the calls coming in. But let's go ahead and do what I would have thought to do, just looking at this. I would have put 3 everywhere I saw an x, and then I would have put a negative 4 in place of all the y's. Now, again, I'm going to say the reason I would do that is it didn't ask you to simplify and get a simplified expression, although we certainly could, but all it would do is be taking away the parentheses here. But we'll work it both ways because I've had some folks work it both ways on the Facebook production today. So let's see what we do. First of all, let's put a 3 in for our x. That sounds easy enough to do. And I'm going to put a little box here, a little bigger parenthesis there because I'm substituting, but I'm going to have 2 times 3, and then we're going to put the plus 5, and I'll put a kind of a bracket there so we get that a little better. And we're going to say 3 times our negative 4, and out here we're going to say 6 minus, and this is where we like to put these parentheses around the negative 4, so it's a substitution. And we are going to need to do it just like so. We're going to work this in basically some nice little steps. So we're going to work left side, we're going to work right side. Lots of things going on. By the way, let's go ahead and change that. Subtracting a negative kind of bothers me. Let's go add the opposite. Go ahead and put 6 plus 4. Now, we're going to simplify inside the parentheses. We're going to simplify outside the parentheses. We're going to work things out here, all right? So looks like here we have, my goodness, what do we got? We got a negative 12. And we have looks like a nice 11 happening here. I'm going to put 11 right there. We're going to multiply. Then we finish this, kind of put this thing to a screeching halt. And let's go work over here with another, oh my goodness, another negative 12. How about that? Didn't see that one coming, I bet. And we'll multiply that by 10, because that's what 6 plus 4 gives us. A lot easier to work with, much easier to play with here, per se. Now, let's see where it's going to take us. We're going to get a negative 12 times 11. Now, my friends, do we have our 12s? You know, another way we could do this, we could have said negative 12 times, what, 21? But I kind of like splitting it up because these numbers are a little more manageable than trying to multiply by 21. Did everybody see that one coming? So how about it? A negative 132 from our multiplication facts in the 12s. And out here we've got a negative 120. And I think we're ready to add these together. And I'm seeing a negative 252, which seemed to be in agreement with some of our folks on Facebook. All right. Mentioned that someone did it with using the distributive property and then just substituting in the situation and just basically adding results, working it through and adding all the results together, and should get the same thing. I think they did. I think it was between Denise and Mark and Margie and other folks. My goodness, it's been a busy day on Facebook, it looks like there too. So let's check it out and see if we get the same reaction when we get a distributive property situation. I'm going to rewrite down here. Negative 4x, and then we got 2x plus our 5, and we're going to say 3y times 6 minus y. We're just going to work the distributive property. Then Then we're going to evaluate. We're going to look at our substitution in after we get all these squareds and other good fun things here. So I'm seeing a negative 8x, and we raise that to the second. Don't leave it just x, folks. You've got to make sure we do that. Minus, woohoo, 20x, because we got to do that distributive, right? Now we're going to go over here and we're going to say, oh, 3y times 6. That one's fairly straightforward. That gives us what? 18y. And then we're going to put minus 3y squared. I'm hoping I've got everything in there right, because there's a lot of stuff to go back and have to fix, isn't it? So let's put a 3 in where we see the x's. So it looks like we're going to have a negative 8 times, 3 squared, minus 20 times our 3. And then we're going to have a big break, okay? Right there, because that's basically what we get from the x's. Now checking through, remember what we got up here? We got a negative what, 132? Are we still going to have that? Remember, do exponents first. Please excuse my dear Aunt Sally. So we got to bring in these exponents. So we got 9 squared times the negative 8. That makes a negative 72. So my goodness, we got negative 72 minus 60, which is good news to me because we got a negative 132 one more time there, all right? Now, plug on over here. Let's see what happens when we put a negative 4 in the problem. Minus 3 times. Oh my goodness, we're sure you square that negative 4 out there. Woo, that's one thing we got to watch out for, especially if we're using a calculator. So it looks like we have another negative 72. And what happens here? 4 squared is, negative 4 squared. Let's go right on this thing correctly. We have a positive 16, but we got to multiply by what? That negative, 3, which is going to give us a minus 48. And I'm already seeing all these are negatives, which is beautiful. Remember what we thought the left side gave us negative 132? It still does. Isn't that awesome? And on the right-hand side, we still get a negative 120, which is still going to come out to give us a negative 252. So however you slice it, whether you did the distributive property first or whether you did your evaluation first, you got it, negative 252. And we're off and running. I'm hearing phones ringing. We want to hear more phones ringing. Give us a call. That number is, you got it, 844-686-2378. Now, I want to pay a little tribute here before we head to into the show. I want to show y'all something that happened on Tuesday. Many of you may not be aware of, but if we can go to my graphing calculator screen, we have a fan here, all right, a Mathline fan. And I don't know whether you can read it there or not. I hope you can. But it says here, Mathline is educational and entertaining for the entire family. If you'll notice, this happened on Tuesday. This was our Solve for P problem of the day. And this dog's name is Peach. P for Peach. How about that? Michelle, thank you for sending in a copy. We are catering to everybody, all right? We're going for the dogs. We're going for the people. We're getting all ages. And actually, I saw one hidden back in my Facebook post, had me spotted with a cat watching the show. And, we pop up everywhere. So thank you, Michelle, for sharing that with us. And, folks, hope you had a good time with that. We just want to have you a little fun with that. But we definitely want you all to be with us, all right? Give us a call, all right? That number, 844-686-2378. I mentioned Facebook. Let's talk about it a little bit here, okay? Like us, love us, and like a lot of you are doing on the little dog post, you're sharing us, but share our problems of the day. Share just general. And a lot of you come in and just like the problem, like the page, all right? Love the page. Just take care of us, all right? We want to have you as part of us. By the way, it's www.facebook.com/Mathline online. All right? We have a call waiting? We have a call waiting? Oh, welcome to Mathline this afternoon. And who am I talking with? Are we there? Welcome to Mathline. Who am I talking with? Are they shy? Okay. Sounds like they're kind of shy there. So give us a call back and we'll try to get you on there, okay? Yesterday, we've set up a little problem going here. This rectangle, we'll try it again. Triangular prism. Woo! Surface area of a triangular prism. We got rectangles floating around in here. We got right triangles. We got 2 of those. And we had 3 rectangles. Now, yesterday we got started. We had some great calls yesterday. So we always break away when we have calls. So folks, don't just get excited about what I'm doing here. Give us a call, all right? Tell us what's going on in your world, and we would love to hear from you. But our storyline here today is let's take 2 right triangles and 3 rectangles. You say, well, Ernie, where are the right triangles? Here they are, right there, a little boxing, okay? And each of these, they almost look like parallelograms, but when they fit together, because it's a right triangular prism here, these are all nice little rectangles. Oh, there's one on the back side too, the 5 by 9 there, okay? So again, it's kind of a little distorted, a little bit out of shape there, but you get the idea, all right? So again, what we're going to do, I understand we have a call back. So we are going to come back to this problem. This has become like a problem of the week, you know, but it's good. We'll take care of it here in just a second. We always want to take care of our callers first. That's part of our game plan. By the way, you go ahead and get lined up on the road to get in to talk with me, folks, by calling 844-686-2378. Finishes out the dialing. So welcome to Mathline. Who am I talking with this afternoon?
Michael.
Michael, good to hear from you. And where are you calling from? What county, what city?
I'm coming from Campbell County, Terryville.
Excellent, excellent. Glad to hear from you this afternoon. And what kind of math problem you got for me? What can I do for you?
How do you solve the equation 3.5x minus 12 equals 30 plus x?
All right, so let's go back again. 3.5x, right?
Yes.
And what are we going to do on the other side of it? Keep going with me on that, if you will. Go back. I didn't hear all your presence there. 3.5x?
Minus 3.5x minus 12.
Okay. And that equals to?
Equals 30 plus x.
30 plus x, okay. Good old linear equation going on here. So what we're going to do in looking at this thing is we have, if you'll notice, a situation where we've got variable on both sides, and we need to move some things around. So you with me so far on what we got? I got it right up there now, don't I? Everything looks right? And
yes.
All right, so let's play this thing out. First thing I'm going to do is I'm going to take the x off the other side. Okay, we're gonna let this go away. Just makes the problem look a lot easier. And what's happening here is I'm subtracting 1x from 3.5x, all right? And in doing so, what's going to happen here is I'm seeing 2.5x. See where I got that? Just taking 3 minus 1, keep the 1/2. Are you with me there on Michael? See what happened?
Yes.
And we got a minus 12 equaling over here. Now these x's are gone, so I'll put a big X through them. How's that? Equaling to our 30 value. So far, so good. I like it. Now, what we need to do is from here, move that 12 over. And that's where things get a little more interesting here. What are we going to have? What's going to happen to us? Well, we're going to have to add 12. Because what happens is we want those to cancel out. So we've got a minus 12 and a plus 12, and we're going to say goodbye to those. And that's going to give me 42 hanging out here. And over here, I have 2 and 1/2 x. Now, we're still got an equals going, all right? So what I'm going to do, I'm going to just use a nice little equivalence here. Let's go ahead and say that would be as in, how about it? Let's use 2.5. Let's go with decimal form, 2 5/10, all right? That's going to be a little bit easier for us to divide. We could also make that 5 over 2 and use a reciprocal. I may go over that here in just a second, all right? But let's do the calculator on this one. I'm not sure if this one's going to pop out even or not, but we're going to make it work as best we can. So we're going to take 42, we're going to divide by 2.5, 2.5 or 2 5/10. And we get, okay, that's not bad. Get 16 and 8/10. That works well. 16 and 8/10 there. Now, the question is, does it check? And I'm going to go back and go ahead and, since we got a decimal form here, as a fraction, that would be 16 and 4/5, all right? Which will work great, all right? Which will work great as a substitution. But let's see if it works out in our grand scheme. It should check, all right? So let's go ahead and make a decimal out of that. And we're going to take 16 and 8/10 right there. We're going to subtract 12, and we're going to see if we get 30 plus 16 and 8/10. And did I stay on the page? I stayed on the page. Yay. All right. So quick check on this. Let's see. I'm going to clear out what we had there. Let's go back to the calculator. There's a little bit of complicated multiplication going on here. 3 5/10 times, looks like we're saying 16 and 8/10. And we're going to subtract 12 from that and see what we end up with on this left-hand side. We got 46 and 8/10. And I'll tell you something. Michael, I can go ahead and add 30 and 16 up there. You see where that's going to go? That 30 and 16 is going to be what, 46? And I've got the 8/10 that runs along, so it does check back out, all right? And folks, once again, if we wanted to fraction on that, since we did start with a 3.5x, sometimes we think we like to go to fractions. That's not going to take much effort. We just simply write it as, well, let's see, I'm out of room here. 46 and 4/5. That would be the reduced, I'm sorry, yeah, we 46 and 4/5 on both sides, and it would be 16 and 4/5 for your x value. So thank you from Campbell County. Good to hear from you. Appreciate it. Thank you for calling this afternoon. And understand we have maybe our caller back or a new caller. Welcome to Mathline this afternoon. Who am I talking with?
Nathaniel.
Nathaniel, how are you doing today?
Good, how are you?
I am doing well, thank you. It's a Thursday afternoon, and it's a great afternoon to be watching Mathline. Where are you calling from?
Knoxville, Tennessee.
Knoxville, Tennessee. Great to have you with us this afternoon. What can I do for you? What kind of problem have you got for me?
Fill in the table using this function rule.
Okay. So I've got a feeling, do you have a table going here of some sort?
Yes, sir.
All right, give me, and do you have a function rule already given to you?
Yeah.
All right,
Yes.
Give me that function rule. It's an f of x, I bet. Is that right?
Yeah.
All right.
Y equals 28 minus 2x.
Okay, 28 minus 2, and you've got it in y equals form, right?
Yes, sir.
That'll be fine. Folks, f of x and y are just, f of x is a nice fancy placeholder for a y value. So we've got a table going on, right?
Yes, sir.
All right, so we have x and y, I'm
And y.
assuming, yeah. All right, now, are you going to be given the x's or are you going to be given y's here? Or are we going to do a mix of both?
X's.
All x's, okay, that works nicely for us here. And by the way, folks, we could solve, if he gave me a y, we could figure out what x is. It just works back and forth here. So let's see, Nathaniel, give me some values for x that you've got. What have you got?
2, 3, 5, and 6.
2, 3, and 5, and 6. So 4 different possible situations here. Sounds great. Okay, let's see what's going to happen with these. I have, first of all, the whole idea is, and I'm going to use, since you've given me y equals, I'm going to use this approach right here, okay? So the first thing we're going to do, we're going to say y equals to 28 minus 2, and we're going to put in a 2 for x. Does that make sense? Does that sound like what your instructor, your teacher has been telling you to do?
Yes, sir.
Okay. Now, key thing, and everybody out there listen to me closely. This is like my dear Aunt Sally. We have to multiply before we can subtract from 28. Does that sound familiar? My dear Aunt Sally, multiplication division comes first, then we do add and subtract. So in this case, it looks like we got 28 minus the 4, and that's going to give me, it looks like 24. Does that sound good to you?
Yes, sir.
Follow what we did, all right? Now, my next one, I'm going to draw a little line here because that got us to the 2. So we got 2 and 24, which makes a nice ordered pair out here, and I'm going to run them out there also. So it's 2, 24. So if we were trying to graph those, we would find that there. Now, with a 3, I've got y equals 28 minus the 2 times our 3 there. We're going to put the 3 in the parentheses. That's what we're replacing, right? And that's going to give me 28 minus 6. Nathaniel, what do you get? What do you see when we get 28 minus 6? What value is that going to give us?
That's going to give us 22.
Exactly. So there we go. So we now have another point. 3 and 22. Continue to play on this a little bit. Let's see what happens. I bet you can tell me what I'm going to do next. I know we're going to skip 4, aren't we? We're going to go to 5. So let's run 28 minus, guess what? 2 times, put in for x, put the 5 in. Is this pretty easy now?
Yes, sir.
It is, yeah. So we got 28. What's 2 times 5 going to give us? That's one of those things we got in our head. Yeah. And subtract, you're going to get?
18.
18. You're on it. Way to go. And last but not least, let's pick up 25 minus 2 times, or excuse me, 25. Boy, I'm jumping here. 28 minus 2 times 6, which is going to be, you tell me, 28 minus what value then?
It's going to be an 18. I mean, not an 18.
You got it. Go ahead and finish. We got 28 minus 12, right?
Well, yes,
So you're
sir.
going to have how much? 16?
Yes, sir.
Okay. And if you were to line, and by the way, that's our other, some word pairs we got. We got 5 and 18 and 6 and 16. And I'm going to tell you, if you were to put these points, plot them on a graph, and you probably want to scale it because those are some big numbers, aren't there? And this is what we call a linear, so they should line up and make a nice straight line for you. Does that work for you?
Yes, sir.
And if you had your missing 4 in there, we could have 2 times 4, which would give us 8. And we have 28 minus 8, which would be 20. And guess what? That fits right in the slot here. Because I'm going to slide it in there just for fun. Because folks, notice as we went up 1, these do what? They drop down by 2. And that's what the minus 2 is all about. Okay? Does that make sense?
Thank you.
All right. Thank you. Thank you for calling us this afternoon. And folks, Nathaniel, and we had our friend from Campbell County. Gosh, I've forgotten his name already. But those folks have given us calls. We've got some more time here, all right? This is our last live show for this week. We've had some calls every day of the week. We've had some great moments, and we want to have a few more, all right? So give us that call, 844-686-2378. Because as you all know, if you call, I guess we won't ever find out about this surface area problem, but let's do it anyway. All right, let's go to the surface area problem here and see if we can finish this thing out here and still give us a call. By the way, if you should call at the very end of the show, if you will hang on the line, even after we go off the air, I can talk with you, okay? We can work it through. We can talk to me in the studio. Just won't be able to have the visual on the air live on it. But so go ahead and give us a call. Even if we get you at 626 or 627, we'll be glad to take care of you, all right? So let's take a look at these little things. 2 right triangles. They are 3, 4, 5 here. That's the sides. Because remember, we start out with 3 and we start out with 4. And we use Pythagorean to find that 5. Because that's the only thing that's missing on this figure. And we have a 5 back here on this little broken dotted line here because that's hidden from our view. So we have, first of all, 2 right triangles. The area, how we do that, we take 1/2 base height, all right? So we're going to say 2 times, and we're going to put a 1/2, and I'm going to use A and B, altitude base or base height, however you want to look at it. And there are 2 of those. They're the exact same story. So let's put a 2, and let's go ahead and find out what one triangle is going to give us. That's 1/2 of 3 and 4. And my goodness, by that part, I can think we can go ahead and say 2.5 go away. But actually, each triangle is worth 6. And that would be square, looks like kilometers here, all right? So that is going to come out to give us 12. And I'm going to put it in here, square kilometers, okay? Now, let's go over here to this second part, this 3 rectangles. They're all different. They're not all the same. But what we can do here, nice formula, is take the 3 parts of the triangle, the 3, 4, and 5. We will take those, and we're going to say 3 plus 4 plus 5. That's the perimeter, because that's how we find what we call lateral surface area. And these rectangles are lateral surface areas, okay? And put them all together. How much? Oh, they're all by 9. All these are 9s going across here. So we're going to take this value times 9. And that's going to be pretty easy. It's going to find and then we're going to add the results together. How about that? Because that's what I said. We're going to find 2 right triangles. Then we're going to add up these 3 rectangles together. By the way, the rectangles, if we separated them, 3 times 9, 4 times 9, 5 times 9. Guess what? It's the same thing as saying, oh, how about it? 3 plus 4 plus 5. And what does that give us? That gives us a big 12, right? Big 12 there. Times 9, which I think that's probably just 6 1/2 dozen. Yeah, you hear me say that a lot. In this case, it's going to be 9 dozen, all right? So, but let's see what happens when we multiply. I believe we're going to get 108. And that is the square kilometers. Big stuff there. So let's put a plus between these, and that should give us how much? Looks like 120 kilometers. Another way we can write them, squared there, okay? There's your total area, surface area. We waited a long time for that one to come out. It took us 4 days to get through it. That's a good sign. We've had a lot of good calls, a lot of good folks calling in this week, and we appreciate that. Now, next week, we are going to be right back here live again, but tomorrow, let me tell you a little bit about it. Specialized segments. Oh, my goodness. Should you miss us, you can always pick up some of those specialized segments on YouTube, all right? And YouTube, let's see what we have for that. How do you subscribe to our YouTube business? www.youtube.com, and we do a / with Mathline there. So very straightforward, easy. There's not an online attached to that. So just go Mathline, you're in good shape. Now tomorrow, like I said, we're back to Trig a little bit. All right, we're going to have some fun with Trig tomorrow, and infamous Chief Soka Toa coming back with us. I want to also give a shout out to WVLT TV Channel 8 here in town, in Knoxville area. They did a nice article segment on one of their newscasts, and actually the evening and morning newscasts about Mathline. Came in and shot some of our show with Gary Petco and myself. So I appreciate that so much. Justin, thank you, the reporter who did a bang-up job. And folks, thank you again for watching and letting us know it was there, all right? And thank you for tuning in. Check us out on Facebook. Check us out on YouTube. Check us out everywhere, anytime. And we will see you again next time.